Welcome to my YouTube channel. Learn fast with this basic video tutorial on generative AI. Generative AI, ChatGPT, prompt engineering are the whirling around all walks of life nowadays. Generative AI is a general purpose technology that is useful not just for a single application but for a lot of different applications that span many corners of the economy. It is creating many new types of job opportunities, and generative AI and associated technologies have a very promising future. This technology is still very new to many people, and few people really understand and know how to use it. So, a lot of upskilling and reskilling are necessary to become professionally ready to work on these technologies. A step-by-step guidance is required for where and how to start and move forward along a judiciously designed learning path through a well-organized course. It is very important to start with the basics of generative AI and gain a clear understanding of the same to learn further and go deep to work on real-life projects. This video tutorial covers the introduction to the key topics that are necessary to prepare individually in detail for a basic understanding of generative AI technologies with practical tips and tools. This tutorial can be useful for high school and college students to prepare for a prospective future career and for professionals with or without computer science or information technology backgrounds upskill and reskill and well position themselves. I believe that you will truly benefit from this 100% free information. More videos will come up to delve deep into prompt engineering, transformer models, large language models, ChatGPT, and other. All I request you in return is to hit the like button and subscribe to my YouTube channel. Thank you. Let's dive directly into the course right now. The major topics to be covered in the course are shown here. We'll shortly watch a very short video to this to have an idea on the basic difference between artificial intelligence, machine learning, deep learning, and generative AI.
In the blink of an eye, the world of technology is evolving, and at its forefront we find artificial intelligence. But what exactly is it? Simply put, artificial intelligence is the broad science of mimicking human abilities. Picture a large, all-encompassing umbrella. Now, under this umbrella, we discover machine learning. It's a subset of artificial intelligence that trains a machine how to learn, making our lives that much easier. It's like teaching a child how to ride a bike. Once they've learned, they never forget. Take another step under this umbrella and you'll stumble upon deep learning. This is a technique for implementing machine learning. It structures algorithms in layers to create an artificial neural network that can learn and make intelligent decisions on its own. It's the brain inside the machine. Lastly, we have generative artificial intelligence. This is a form of deep learning that allows machines to generate new content. From creating beautiful artwork to writing sophisticated pieces of text, generative AI is the artist in the world of artificial intelligence. In 60 seconds, we've journeyed from the broad expanse of artificial intelligence to the creative depths of generative AI. Technology truly is a fascinating world, isn't it?
From the video that you have seen, we can understand that artificial intelligence is a broad science that is mimicking human intelligence. It is a broad umbrella technology or the superset. Next comes the machine learning, which is a subset of artificial intelligence. And then is the deep learning, which is a technique to incorporate machine learning and is a subset of machine learning. And finally, the generative AI, which is a form of deep learning to create new content. This subset of deep learning is marked as red in the Venn diagram. Now, let's quickly understand the basics of deep learning and artificial neural network. Deep learning is the subset of machine learning that uses artificial neural networks to learn from data. Now, artificial neural networks are inspired by the human brain and they are made up of many interconnected nodes called artificial neurons organized in layers that can learn to recognize patterns in data. There can be one first layer called the input layer and one last layer called the output layer in an artificial neural network. But there can be one or more in between layers called the hidden layer, as we find in the shown example. The deep in deep learning refers to the number of layers in the neural network. A deep learning neural network uses artificial neural networks with many layers, each of which learns to extract the different levels of features from the data. For example, the first layer might learn to detect the edges in images, the second layer might learn to detect shapes, and the third layer might learn to identify objects. The final output or output class is termed a label. In the given example, cat is the label as detected from the input images through the training of the neural network, considering the input features at each level. Now, the main architectures of deep learning are convolutional neural network CNN, recurrent neural networks RNN, generative adversarial neural networks GAN. Finally, a few important applications of deep learning are natural language processing NLP, image recognition, speech recognition. And these have been widely used in generative AI, including large language models. Now, before going to talk about deep learning models, let's quickly brush up the basics of function and model and how they are related. We find that a mathematical function f is a binary relation. It is a mapping between the two sets capital X and capital Y, where X is called the domain or the set of independent variables or the possible inputs, and Y is called the codomain, set of dependent variables or the possible outputs. Now, standard mathematical expression of a function is y is equal to fx, and this is very common expression where this f is basically a model. F represents or analogous to a model. An input can be exactly assigned to one output. This is quite important, that one input can be exactly assigned to one output. And what is a model? A model is then a mathematical function that maps from domain to the codomain. It calculates the output of a process given different inputs. So I repeat, in the expression y is equal to fx, f represents a model. Deep learning models are of two types. One is the discriminative model, another is the generative model. Discriminative models are also referred to as conditional models. They are a class of logistic models used for classification or regression. It is used to classify labels or predict data points. It is typically trained on a set of labeled data points. It learns the relationships between the features of the data points and the labels. It also learns the decision boundaries through the observed data. For example, classifying an image as a dog or a cat, as shown in the given example, is a type of discriminative model. Next comes a generative model. Generative model generates or recreates new data instances based on a learned probability distribution of existing data. For example, producing a realistic dog or a cat image from the existing images is an example of generative model as shown in the image here. And generative model can be trained on labeled and unlabeled data both. Here in this example, we like to show the difference between the discriminative and generative models through a statistical terms or the probability distribution. Discriminative model learns the conditional probability distribution of the probability P y condition x, where y is the output given x as the input, that this car is a car, and classify it as a car and not as a cycle in the example shown. But in case of generative model, it learns the joint probability distribution of the probability Pxy of input x and label y and predicts the condition and probability that this is a car and can generate a car picture, as shown here as a new car generated in red color in the given figure. Now I am going to give some preliminary ideas on two important generative models which are the foundations of generative AI. These are Transformer Model and General Adversarial Network, GAN. A transformer model is a neural network that learns context and thus meaning by tracking relationships in a sequential data like words in a sentence. A generative pre-trained transformer GPT is a transformer that can generate coherent and contextually relevant text based on a given prompt. Transformer consists of two parts, namely encoder and decoder. There is an attention mechanism or self which is used by the transformer model to see one or more entire sentence at once rather than one word at a time. This allows the transformer model to understand the context of a word better. To process a text input with a transformer model, the input text needs to be tokenized into a sequence of words. These tokens are then encoded by the encoder as numbers and converted into embeddings, which are vector space representations of the tokens that preserve their meaning. Next, the encoder in the transformer transforms these embeddings of all the tokens into a context vector. The context vector carries the essence of the entire input. Encoder model processes the input sequence using the self-attention layer and position-wise feed-forward network components to create a fixed-length representation of the input sequence. The decoder implements this representation to generate the output word in a sequence, one word at a time, using similar self-attention and position-wise feed-forward network components, and as shown in the given figure. Let's now move to Generative Adversarial Network, GAN. GAN is popular for generating mainly images, music, and even text. GAN has two parts or adversaries consisting of two artificial neural networks, a generator and a discriminator. A generator is trained with real data sets covering images, text, audio, and others, and a discriminator is trained with real samples from the training data and generated samples from the generator. It generates samples that resemble the training data set it was trained on. The discriminator tries to classify real data as real and generated data as fake. The role of the generator is like a thief to generate the fake samples based on the original sample and make the discriminator fool to understand fake as real. On the other hand, a discriminator is like a police whose role is to identify the abnormalities in the samples created by the generator and classify them as fake or real. Next comes the foundation model, which is a large artificial intelligence model which is pre-trained on a massive dataset to fine-tune to a wide range of downstream tasks like question answering, sentiment analysis, image capturing, object and so on. It is called foundation because it provides a base layer of knowledge and capabilities upon which more specialized models or applications can be built. Transformers, large language model and other new models are part of it. It is coined by some researchers at Stanford University, and it can centralize the information from all the data from various modalities like text, images, voice, 3D, structured, which can be both labeled and unlabeled. Important thing, that is large language model or LLM. It is actually a deep learning model designed to understand and generate human-like text based on the input it receives. It follows a transformer architecture which is trained massively on large datasets with a few billions of. It is fine-tuned to train on narrower dataset to specialize in specific tasks like text generation, translation, question answering, summarization, classification. There are few popular LLMs like GPT-4, which is from OpenAI, Lambda and Palm from Google, Llama 2 from Meta. ChatGPT, which is very popular recently for the last few months is basically a chatbot which is based on GPT 3.5 and later upgraded to GPT 4 also. And finally, I'll cover a little bit on prompt, which are basically the inputs that are fed into the LLM to get the desired output. Prompt engineering and prompt design are two important aspects which are very much associated with large language model, and these will be covered separately in a separate video. With the background knowledge and understanding you have so far, you are now in a better position to gain a clear idea of what is generative AI and how it works. Generative Artificial Intelligence is a subset of deep learning that creates new content, including text, images, 3D objects, video, audio, and computer code, in response to the prompts written in natural language conversational interfaces. This content generation is based on what is learned from the existing content. The process of learning from the existing content is called training. It is trained on both labeled and unlabeled data using supervised, unsupervised, and semi-supervised methods. This training identifies patterns in large quantities of training data through statistical analysis of the distribution of words, pixels, or other elements in the ingested data, and then creates new original material that has similar character. Generative AI can be text generative, image generative, audio generative, and so on, depending on the type of content generation. Text generative AI uses transform architecture like GPT, while image generative and audio generative AI uses GANs or diffusion technologies. For example, in the case of text generative AI, given some text, it can predict what comes next, while in the case of image generative AI, it generates new images or related imagery. So, it can be said that generative AI is an umbrella term for foundation model, transformers, large language models, diffusion models, and other related neural networks, as it can capture people's imagination to create text, images, music, software, and more. Now, let's understand a bit about unimodal models and multimodal models of generative AI. Generative AI models can be categorized into unimodal and multimodal. Unimodal models are designed to accept a specific raw data modality as input, such as text or images, and then generate predictions in the same modality as the input. Data is multimodal in some domains. Multimodality refers to the ability of a generative AI model to generate outputs in different modalities such as text, images, or audio based on the input it receives. We have already learned that foundation model can centralize the information from all the data from different modalities. Multimodality in generative AI models is an emerging and rapidly evolving field that is revolutionizing the way we interact with the technology and each other. Multimodal generative models can combine multiple modalities to generate more diverse and emerging outputs. For example, a multimodal generative AI model trained on both text and images can generate a description of an image or a corresponding image given a text input. A chatbot equipped with a multimodal generative AI model would respond to a user's request with a text response accompanied by an image or a video clip, making the interaction more engaging and memorable. In healthcare, it can combine multimodal data like patient medical history text with medical images and sensor data for better diagnosis. An overview on how generative AI works. There can be 4 key steps that are usually followed for generating new content. First step is to collect a data set that represents the kind of content you want to generate and train the generative model. This dataset can consist of text, audio, code, or other form of data. The data is usually collected from web pages, social media, and other online media. The dataset is then pre-processed to ensure it is in a suitable format and to normalize or transform the data if necessary. The second step is a model training and latent space representation. A generative model is trained using the pre-processed dataset. The choice of model depends on the type of data and the desired output. For text-based generated outputs, a transformer model is preferable, while generative adversarial networks GAN and variational autoencoders are preferable for generated image, audio, and video outputs. During training, the model learns the underlying patterns and structures in the data, capturing the statistical distribution of the training examples. Latent space generally refers to a compressed, often lower dimensional representation of the input data that captures the most important features. It is a space where similar data points are clustered close to each other. It is prevalent in models like autoencoders or generative models where the encoder produces a latent representation of the input. The latent space representation is also learned by the transformer model during training, and it is used to generate output sequences or to perform other tasks. The third step is the generation process. In case of text generative AI, once a transformer model, say a GPT, has been trained, the prompt or the input text is broken into a sequence of words called tokens that are input to the GPT. GPT then uses statistical patterns to predict likely words or phrases that might form a coherent response to the prompt. Predicted words or phrases are then converted into readable ones. The process is repeated till it reaches the last token or encounters some predefined stopping criteria. In case of the image or audio generative AI, a GAN or in combination with VAE is used. For example, a successful GAN trained on a dataset of thousands of landscape photographs might generate new but unreal images of landscapes that are almost indistinguishable from real photographs. And finally, the fourth step is the evaluation and refinement. The generated content is evaluated based on various metrics such as visual quality, coherence, or relevance to the desired output. Feedback from the evaluation process can be used to refine the model or guide the generation process. Iterative training and fine-tuning are often employed to improve the quality and diversity of the content. On generative AI models for different inputs and output data modalities. The different inputs, as denoted by capital X, can be text or image, audio, code, video, and 3D, and corresponding outputs also. So here, some important and popular generative AI models have been shown. Now, I am going to show two examples of text to code generation and then text to code conversion. For this, I am going to use well-known ChatGPT, or rather the GPT. I have already logged into ChatGPT and I will now type out the prompt binary classify and let's see what happens. We find that a code is being generated with some documentation or comments at the beginning of each activity, and finally we find that the code has been generated. Next, I will ask ChatGPT to convert the Python code to Java by writing a prompt convert this code into. See, it has started converting. It is using some different library in Java. Earlier in Python it used skit, which was specific in Python, but here it is using Weka. So in the code that is generated, it has used Weka library, and finally the code is generated. Let's see another live example of an image generation from text using the generative model. Here I am using the latest model, Adobe Firefly. I log into Adobe Firefly and type out a prompt in the section text to image. What I am going to type out is the photo of an riding a horse and see what it generates. See, it has created 4 pictures in different ways and different looks. So you can select a particular picture, or you can refresh and create fresh ones. So in this way, the pictures. Generative AI models can perform several tasks with text as input and image, audio, video, and code as outputs. Similarly, with image or audio as inputs and other data types as outputs. This is represented here in a matrix form. This task can be utilized in various application domains like creative content generation, education, product development, customer service. In creative content generation, it can be used to generate creative content such as text, images, music, videos, images, 3D images, code, and gaming. For example, ChatGPT or GPT-4 can generate text, translate languages, write different kinds of creative content like stories or poems, edit or rewrite content, translate languages, and answer your questions in an informative way. It can be used to create chatbots, generate marketing content, or write blog posts and create autocomplete or convert code. Again, DALL-E, image generative tool, can be used for variety of purposes such as healthcare, creating art, marketing materials, illustrating children books, or designing new products. ChatGPT now integrates with DALL-E 3 to generate detailed images. In education, it can provide or improve rather the education with providing students with personalized learning experiences and creating interactive educational content. In product development, it can be used to generate new drug candidates, design new materials, or create new software features. And in the customer service, it can be used to improve customer service with personalized support like chat or emails and automatic tasks. Finally, generative AI is a rapidly evolving field with newer applications being discovered all the time. It has the potential to revolutionize many industries and make a positive impact on society in many ways. To learn and understand generative AI, it is essential to practice and implement the concepts. I am providing some practical tips along with the corresponding resources. I am now going to discuss 8 useful steps that need to be followed along with the help of the referred resources. Step number 1. You have to brush up your basic knowledge in statistics, linear algebra, programming, data structure, and algorithms. It is important to refresh yourselves on areas like regression, probabilities, matrices, vectors, calculus, and computer basics, including programming concepts and algorithms. Step 2, you need to understand the basics concepts of artificial intelligence, machine learning, and deep learning. You can refer to free online courses on YouTube, Coursera, Google, and understand classical machine learning like supervised and unsupervised techniques and algorithms on regression, classification, clustering, pattern search, and dimensionality reduction and visualization. Also, get yourself acquainted with reinforcement learning. The step 3 is to learn the relevant programming languages, especially Python, which is powerful and well suited for this machine learning and deep learning. Practice writing Python code regularly and do thorough tests to clear all your basic concepts. This is to be followed by the implementation of the learned machine learning. Now, step 4 is to understand Python libraries like NumPy, Pandas, Matplotlib, and Skitlearn and get hands-on experience with them. You study the libraries and practice implementing them through small projects with assistance from the mentioned websites. This will help to deeply understand the relevant applications of the libraries. Now, step 5 is to learn about artificial neural networks and deep learning. This is an important step. Deep learning, which is based on artificial neural networks, ANN, is the backbone of generative AI. Understand the architecture and algorithms of a few important ANNs like multi-layer perceptrons, MLP, evolutional neural networks, CNNs, and the Generative Adversarial Networks, GAN. Also, understand the difference between ANN and deep learning with applications. Explore the associated Python libraries and implement them through small projects with the help of the referred websites. Step 6 is to understand the generative AI. Start with a few simple tasks like generative texts, code generation and conversion using ChatGPT or GPT, also creating simple images or music. Try to develop the art of writing effective prompts to get the desired results in these tasks. Understand the basics of attention mechanism, transformer architecture, foundational model, and large language models LLM and their application. Now step 7 is to gain practical experiences through projects. You follow GitHub or Google Play AI platform or OpenAI to know about the available projects. Take the help of the mentioned sites and utilize the available free datasets like in Kaggle to develop simple to complex projects. Explore various ChatGPT plugins as available in GPT-4. Create own custom LLM-powered chatbot. This is in growing demand. Also deploy generative AI solutions in Google Cloud. Participate in Google competitions to build a portfolio of projects. Now the final step, the step 8, is to stay updated and adapt your learning. Continuously upgrade your knowledge by becoming members of various relevant technical committees, social media, and study related research papers and blog posts and attend webinars, workshops and seminars. Here is a list of useful research papers and blog posts that I have referred to prepare this video. These might be helpful for you too. Hope by now you have a fair idea of generative AI and its importance. Thank you for watching this video and do make sure that you subscribe to my channel. I'll see you soon in my next video.